So now, as I understand, we move to English because we have an English speaking panelist. We have the next panel here entitled Use Cases and Alternative Solutions for Hydrogen and E-Drives. I'd like to welcome Dr. Claudio Fiorentini. He is Managing Director, Global Major Accounts and Special Projects by JCB. Welcome.
Nice to meet you.
Nice to meet you. You want to take
you.
a seat here?
Thank
The
you.
more comfortable one.
Yeah.
Second, I'd like to welcome Burkhard Jansen. He's European Department Head, Special Applications and New Technologies by Hitachi Construction Machinery. Burkhard, herzlich willkommen.
Guten Morgen.
Morgen. Finally, Markus Bollmann. He's Technical Sales Manager, Central Europe by Deutz. Markus.
Schönen Morgen, grüß dich.
Morgen. Morgen. In this panel, we start. You want to take a seat here? So
Okay, sorry.
I'm with my. We start with a presentation by Claudio. Please, the floor is yours. Please look forward to your introduction.
First of all, thank you very much. My knowledge of German is almost inexistent, so I apologize. It will be in English, and I want to show you what JCB is doing for not only for hydrogen, but in general for supporting the decarbonization of the construction industry. I hope this is going to work. Yeah, this is a picture. Don't know. Yeah?
Yeah. I'm asking the
Yeah.
conference technician. Here we go.
Okay. So, I think you, just a very quick introduction of JCB, which is, JCB is now a global manufacturer. Our turnover is about $9 billion last year. And we have almost 80 years of history, and we produce more than 300 models of different machines. Now, obviously, all our machines have a diesel variant, a diesel engine. So the decarbonization is one of the goals that we have in terms of development, and we have decided that we had to have a road to zero, or how to better describe, because of our type of machines, is an off-road to zero, because our machines are mainly working off-road. And we like to make a parallel for our machines. If we take in a graph the hours that machine is working and the energy demand of a specific model, we can make a comparison with road vehicles. Say, for example, with cars, buses, trucks, or trains. And we can say that compact machines are very similar in terms of energy requirements of cars. Why is that? Other type of machines, like medium-sized machines, have an energy requirement more similar to buses and trucks. This depends mainly from how many hours they work and what kind of application they are working in. And if you go into heavy construction machinery, their energy requirements is more similar to the one of very high utilization, like trains and that kind of things. But to stay on the compact machines and the energy demand, we make a comparison saying that a mini excavator, normally speaking, is working 400 hours a year. And if you think to a car, normally speaking, a car is making, on average, 20,000 kilometers per year, with an average speed of 50 kilometers per hour. So, in reality, we are using most of our car for around 400 hours a year. And so, we have established a perfect correlation between a mini excavators and a BMW. So, it's a great step. And, but this is giving you the perception of the fact that, how is it today, say, popular to have an electric car? At the same time, in terms of energy demand, the mini excavators is very similar. So, we have developed a range of electric machines that is in the range of the compact space. Machines that are used for a number of hours, which is relatively low for a type of equipment. So machines that are used in an intermittent way for about 500 hours, maximum 500 hours a year. And we have quite a vast range of these machines. But when you okay, so going back to our graph, so we determine what we call a job site limit. So fundamentally, a limit for machines of a certain size, of a certain dimension, to be effectively used on an electric, with an electric variant. Because also there is one question, which is the time that is taken to recharge this machine and the availability of enough, say, electric source or electricity source to make the recharging of machine effective. When we arrive to bigger machines, then this is becoming more complicated because, first of all, the machines are probably working in a remote environment. And the electricity, the level of electricity, the power that is required to recharge this machine becomes more, is not available on site. So what is our, we are convinced that to make effective the decarbonization, we need to provide a solution which is fast refueling. So the refueling, or say the recharging of the equipment has to be very similar to the process of filling up a tank. And the energy source has to be mobile, because we cannot forget that our machines are not going to the pump to get filled with diesel, but it's the diesel that is, generally speaking, taken to site to refill the machine. So these are the two main objectives of our developments. And there is also another consideration that in the 10 years between 2010 and 2020, we have increased the productivity and the efficiency of our engines, obtaining an average fuel reduction of about 50%. So we have reduced the use of diesel by 50% in 10 years. And these are real data taken from our telematic system. So we have a real, this graph is real, it's not just a drawing, it's a real, but then to go to arrive to a real decarbonization, yes, we can do more efficiency in the engine, and this is an area that we are really active in doing that. But we think that with the electrification of machines, yes, we can electrify efficiently a number of machines, but the decarbonization, the effect on decarbonization that this machine can provide is relatively small because they are compact machines and because the diesel they consume, so the CO2, the emittance of CO2 is relatively small. The real step to arrive to a net zero by 2050, which is the goal in Europe, we need to find something which is far more radical, and that's why the only way to achieve this is to find a carbon-free fuel. Carbon-free fuel that is very limited in terms of what options are available. To this, I like now you to show and to broadcast a video where our founder, our chairman, is telling you what we are really doing on this area.
I'm often asked, why hydrogen? Where does the power come from? It comes from that. That is a glass of water, H2O. You split the H2 from O, and it's possible to do it in scale and around the world.
This is power. The power to move the earth. The power to change the world. This is JCB's hydrogen combustion engine at work. Welcome to the future.
Meeting the UK's ambitious goal of cutting net carbon emissions to zero by 2050 takes a lot of bold thinking, a lot of hard work, a lot of innovation, the kind of thing JCB has been delivering for over 75 years. 2 years ago, almost to the day, I set the challenge that we should be making hydrogen engines for the construction industry and for agriculture. 2 years later, we have hydrogen engines working in the kind of equipment that JCB makes. A solution that delivers power in the same way as conventional engines, but with none of the fossil fuels.
So where did it all begin?
Well, in the early days of the hydrogen story, we believed the only technology available to us was a fuel cell. So we got on, made a fuel cell prototype, 20-ton excavator. We started to understand the complex challenge of putting a fuel cell into a piece of construction equipment. Construction equipment machines need energy quickly, whereas fuel cells were maybe better suited to a more gentle environment. And we started to realize that maybe fuel cells weren't too good for response, were too complicated and too expensive for the market that they serve. We knew we at JCB could do better. The two machines we have on site are game-changing. Firstly, we've got a backhoe loader. Secondly, we've got a construction load haul. What we've done is we've taken our hydrogen combustion solution, we've incorporated it into both machines. We've then worked out how to remove the fossil fuel tank, replace that with hydrogen tanks, and now we've got both machines running. Same characteristics of speed, of of loading, of digging, performing in the worksite.
So what's the secret? It's this.
This is not a conversion. This is brand new combustion technology. We've had to look at almost every facet of the engine, and we've completely re-engineered it to run on hydrogen. It's a zero carbon fuel, and it gives us a zero CO2 solution. We've kept the DNA of the engine. The components are familiar and common. The big difference is the fuel. We've gone to a zero CO2 hydrogen gas. We inject it into the engine. We've lowered the pressure, we've lowered the temperature, and that gives us a clean burn and a zero emission product. We've worked really hard on the performance characteristics of this engine. We've done that to make sure that we deliver exactly the same power and exactly the same torque as the diesel power plant that we've replaced.
But it's on refueling that the hydrogen combustion engine really comes into its own.
Most of our machines, 97% of them in fact, the fuel is delivered every day while the machine keeps working. So we've developed a fueling system, a hydrogen bowser, so we can take hydrogen from the tube trailer, decant it, and deliver that hydrogen fuel to the machines that are working on site.
JCB is the first in its industry with a hydrogen combustion engine solution. But what's needed now is a hydrogen fuel infrastructure, one capable of producing the quantities of hydrogen required to power the solution at scale and transporting it to where it's needed. With investment, that infrastructure could then be adapted to produce the necessary quantities of hydrogen, preferably green hydrogen, enough to fuel our machinery and power other industries too. A practical solution to a global problem. In a world where energy security is now a top priority.
These are more than prototypes. These are fully fledged machines. Working right here, right now at JCB, we're proving daily that hydrogen does work, that it's a clean, renewable, transportable fuel, capable of storing and delivering the power our industry needs, quickly and efficiently, without the carbon. We're working towards a hydrogen future with zero emissions. Surely that's a great benefit for the world.
JCB, always looking for a better way.
I think that there is very little to add, other than for us, the only fuel that is carbon-free and that is possible to use in our type of equipment is hydrogen. Obviously, it's a solution that has given us some challenges, but I think that has a number of benefits that are really massive.
Okay, thank you very much, Claudio, for the introduction.
Thank you.
Of JCB's road to zero and the history, so to say, in the future. Besides you, we have two panelists here, Burkhard and Markus from Hitachi and from Deutz. Maybe you can say a few words about your partnership and also the things you do together in the context of what we have discussed, the way to zero, net zero, which technology are you working on, why to collaborate, what is the success factor in your case?
Okay.
Maybe, I don't know who wants to start.
Yeah, I can start.
Yeah.
So thank you, Claudio. A good summary of the situation. There are a lot of similarities between JCB and Hitachi as OEMs and making construction machinery. So we are, like JCB, a little bit dancing on, at the same time, on different wedding parties. So we also made the experience, and we learned also lessons that you learned, what Lord Bamford explained about fuel cell, and finally going to the going to the direct injection of hydrogen. So we follow a similar way in our approach, but we also see the necessity for this four-pillar approach, which is already explained by CSE. There's a policy paper on that, a strategy paper on that, and most of the OEMs follow that. It's not only new technology, new fuels saving the future, it's also the optimization we are going to do on machine efficiency, on operator optimization, on all the processes on the job site. And we also have to realize, we talk about new technology, it will not start with a finger snip right tomorrow. So we still have a phase in and phase out. We still have a high population of diesel engines in the market, and we will have, from my point of view, in the future as well. So we have to dance, as I said, on different parties at the same time. And our party split up is a little bit different to JCB. We are also looking for mini and compact machinery, so up to 13 ton or maybe up to 20 ton to be electrified. And above that, we also look into hydrogen future technology. It's a good energy carrier that provides a lot of energy for this construction machinery. About the relation to Deutz, so Hitachi has Deutz as a supplier for a lot of machines already, diesel-powered machines, but we also wanted, you must also see Hitachi is a manufacturer not making their own engines, so we have to buy it from supplier, and one of the supplier is Deutz for diesel engine, but the future is electrifying, but also it's looking to hydrogen. So therefore we asked also through a joint venture called KTEC, Kenki Technology Group, we asked Deutz to look into that and work on a solution for that. And there Markus gets into the game here and into the play, and he can explain a little bit more what's going on the hydrogen.
Markus, you can elaborate a little bit more on the technology, what's happening in the engine. Is it going in a similar direction?
That's a similar direction, Claudio.
Yeah.
Yes, we work on diesel, that's right, but we work also on electric stuff, also with KTEC, yeah. But we know that it's not everything. We need to invest more to that technology that we invest in ICE hydrogen engines and as well in fuel cells, methanol fuel cells, for example, right? And the key message is we need to reduce CO2 in the future, right? So that everything what we can do is right, yeah? Maybe it's not possible to make repowering of all machines, all what we here see with hydrogen or electric. I'm sure that diesel will have a future the next 10, 50 years, but maybe with not organic fuel, maybe with synthetic fuel, right? This is one step. And then we come to hydrogen. But hydrogen is a very, let's say, critical stuff today because so far I know more than 95% what hydrogen is using in Germany is gray.
Yeah.
You know what is gray? Gray come from the earth over a reforming process so that we have CO2 with gray hydrogen as well. And the message is reduced CO2, right? So that it's necessary that when we have enough green hydrogen, first give the green hydrogen to all the industrial plants like power, steel, chemical, whatever you want, right? And then when you have green hydrogen, then you can put it to the machine. But for my opinion, produce it here and use it here, right? So that you have, or you need to find a best solution for a good infrastructure there where the machine is working, so that you have short distance for transport of the green hydrogen, right? So, and we definitely see applications where the ICE engine is mandatory. We have different applications like you running as well. Yeah, it's different trucks. We have gensets in China. It's running. We have a truck. It's a founding project with an 18-ton truck. It's still running. And then 2 weeks ago, it was an exhibition for trains. We show the first hydrogen electric-driven train for Stadler. And that is for regio shuttle transport passengers. It's also with the hydrogen engine it's running, right? And then we look in the future. We are here in a construction forum. We talk about excavators, we talk about trams, cranes, whatever, right? And there we see also benefits with the hydrogen engine in that kind of application, right?
Okay. Let me ask one specific question. How many hydrogen equipment did you already sell? I don't know whether this is a secret. Is it just starting, or is it a small portion in terms of percentage?
No, we have not started the commercial to sell product with hydrogen engine for various reasons. Not because of the maturity of the project. The project is mature, but there are a number of regulations to adapt. The first is that our machine are, as you all know, they have to conform to stage 5 emission standard. Hydrogen is by far, the machine with an hydrogen engine is by far, practically it doesn't emit anything apart from a bit of NO2. But you need to certify the engine that is up to stage 5, because the law says that the machine has to have a stage 5 certified engine. So we are in this process of certifying the engine to be legal, in terms of stage 5 and so on. But I think that two things were said that are we are perfectly agree. The first is there isn't a solution that fits all. I think that particularly in our construction sector, in construction machinery, we need probably to adopt a variety of solutions to have, to reach the decarbonization. And for smaller machine, probably the electrification is the easiest way to do, because we cannot introduce certain type of technology in a smaller machine. There are other challenges in the small machine to have them electrified. The first is that we cannot, I don't know if you have ever reflected on this, but an electric car, normally speaking, weighs 800 kilos more than a diesel car. Why? Because there are batteries that are not present into a diesel car, and if you replace the engine, the gain in weight for a car is relatively minimum. But you cannot do this on a construction machinery. If you have a 2-ton mini excavators, you cannot say, because it's electric now, it's 3 ton, because I am adding batteries. No, you need to stay within that weight limit, weight class, because otherwise you have other problems. The undercarriage won't be able to support the kind of weight, the wearing of the componentry is different. So in the electrification, yes, from a technical point of view, is relatively simple, but from a application point of view, it might be simple for a car, but it's not for a construction machinery, because you need to stay within a certain parameters. Now, the same is, if I may add, so even for other type of equipment, maybe we will never be possible to reach certain, but we need to find other solutions to reduce carbon, like, I don't know, hybrid or whatever. So,
Okay, in the end, there will be a mix of applications or a mix of technologies that might be used in the field.
definitely.
Thank you very much. So let me take a few questions here. The first one is kind of concerning about loss of energy. You lose about 50% of the electric energy to produce H2. Then you have transport losses and lose 60% of the energy to combustion. How can this be a better footprint than direct electric or battery, except the availability of electric on site? So, it's losing energy along the way, looking at the entire value chain. So does it make sense to go into H2?
Yeah, it makes sense. I can give you a great example for this question. Because we talk about train, right, and the cables. 1 kilometer costs 1 million euro. So Germany is roughly 60% with cables, right? So that means if you will put the cables on the different 40%, you spend millions of euros to electrify Germany, right? And that is a solution. Let's say hydrogen, you can use it as energy storage, as a huge energy storage, right? And then when you need power, you can use a genset with hydrogen, produce power, right? Yes, we lost a lot of energy, but without, there's no chance to reach the goals in 2030, right?
Yeah, but also transporting electricity, you have a lot of losses.
Yeah, that's right. Over the cables, you lost a lot of power, right?
Yeah, I must admit, so it's not the best way to go, but obviously at the moment it's the preferred way, or the way that's open for us. Just an example for, let's say, a 30-ton excavator. If we want to electrify that, which has the best efficiency, no question about it. So electric power is very efficient. But we would require for that about 800 kilowatt hours battery capacity. You know, a Tesla S model has 85 kilowatt hours. So we have to put almost 10 Teslas on the back side of our excavator. That means around 6 to 7 ton of lithium-ion battery we have to install there. But we get to a place where the infrastructure is not capable to recharge this machine. And there's not only one excavator, there are a lot of JCBs and other construction machines on the site. So everything has to be recharged if it's going electric. One solution is the H2 generator. There are examples in the market, also Hitachi Energy is working on that. And up to 1,000 kilowatt hour and even more in a modular way can be provided on a job site. That's a solution recharged by, in that case, with a fuel cell and with hydrogen, because that's a big difference between on-road and off-road, and maybe also on-rail and off-rail. On-road and on-rail, you can stop the vehicle to recharge at a fuel station, at a station on the rails. Off-road, the fuel station has to come to the vehicle, to the job site. Absolutely. So somehow we have to transport the energy, and at the moment, the most reasonable way, it's not the best way, but the most reasonable way is to go into H2, because it's a nice energy carrier. It provides a lot of energy per volume.
A follow-up question. You alluded to this a little bit in your presentation, the H2 infrastructure. It was kind of a vision, and there's one specific question related to this. Asking for general hydrogen infrastructure seems
but in a sense,
not realistic. As on-road will be dominated by electric vehicles, how to overcome this disadvantage of hydrogen in terms of infrastructure? Where does the hydrogen come from? You alluded to this gray and green hydrogen.
Fully agree to a point, in the sense that that there is already, obviously, nobody wants to build a very, say, dense hydrogen infrastructure. It would make no sense at the moment. But there is a European approved project whereby there will be a network of hydrogen refilling stations in what they call the T5 or T2, I don't remember. The road fundamentally that from North Europe goes down to south over Italy, where there will be a refilling point for hydrogen every 200 kilometers. This means that it will be possible to have hydrogen trucks with hydrogen engine, doing this kind of motorway of hydrogen highway and carrying goods with no carbon emission through Germany, Austria, and so on. It's clear that, again, to reach the decarbonization, there will be multiple solutions, and probably for the cars that are running on motorway and are stopping to the refueling station, electricity will be probably a more convenient option. But if you think to construction machinery, where you need to deliver the fuel on site, electricity is not really the result. And I fully agree on the estimation of Hitachi that for an excavator, you need 800 minimum. To be efficient, you need 800 kilowatt. And again,
so the audience is, I think, concerned with how do we get the hydrogen to the construction site. Let me just take one more question, very related to this. How expensive is it, the refueling of vehicles? How many machines can it support? Is it expensive to refuel? How many machines can it support?
For now, yes. We talk about roughly 15 euros per kilogram. And for example, I would say your machine is 10, 50 kilos, 20 kilos?
Yeah, in terms of hydrogen, it's about 20 to 25, 24, 25. Yeah, you need to give 8 hours of work. Consider that 1 kilogram of hydrogen is equivalent of 3 kilograms of diesel in terms of energy. So you have 1 to 3 proportion, which, I mean, the transport is not, because the hydrogen is you need to compress to have a significant volume to be transported. But again, normally the compression is up to 700, 800 bar in terms of long transport. The vehicle that you have seen in the video was not really specific, was just a tank. Actually, that you can, it's a Bowser that you can put on every truck or whatever, and in that Bowser, the compression is 350. So it fills by different type of compression, and then when you refill the vehicle, in the vehicle the compression is a bit lower again, so the movement of hydrogen is by different compression. It's not, but refilling one of our machines from full empty to fill to 25, it takes 5-6 minutes. So it means that it's similar to the to the diesel.
Okay. We came to an end. Thank you very much. We will have different solutions again. Hydrogen is a solution going forward. It's still, let me call it, in the development phase. It's not scaled out yet. Infrastructure is a challenge. Cost is currently still, or is a challenge. Where does the green hydrogen come from is a question the clients ask. But the manufacturers, together with the engine manufacturers, are working on it. And technologically, it works. That's not the question. That's what I get. Okay, thank you very much to the panelists, Claudio, Markus, and Burkhard. Thank you very much for being here. Let's give the panelists an applause. Thank you.